Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the geometric interpretation of complex numbers, seeing them as points on a plane rather than just abstract algebraic expressions. Let's begin. Every complex number z equals x plus iy can genuinely be represented a point with coordinates x, y on a two-dimensional plane called the Argand plane, where the horizontal axis represents the real part and the vertical axis represents the imaginary part. This same point can also genuinely be described using polar coordinates, the modulus r, which is the distance from the origin, equal to the square root of x squared plus y squared, and the argument theta, which is the angle this point makes with the genuinely positive real axis, giving the modulus argument form z equals r times cos theta plus I sin theta. This genuinely dual representation, Cartesian using x and y, or polar using r and theta, is exactly why complex numbers are so powerful for describing both distances and rotations simultaneously. Addition of two complex numbers z1 plus z2 corresponds exactly to vector addition on the Argand plane, genuinely following the same parallelogram law used for adding ordinary vectors, and subtraction z1 minus z2 genuinely represents the vector pointing from the point z2 to the point z1. Multiplication has a genuinely beautiful geometric meaning. Multiplying two complex numbers multiplies their moduli together and adds their arguments, so z1 times z2 has modulus r1 times r2 and argument theta1 plus theta2. This specifically means multiplying by a complex number of modulus 1 is genuinely just a pure rotation by that number's argument, with absolutely no scaling involved at all. The modulus of a difference, the distance formula, mod of z1 minus z2, genuinely gives exactly the straight line distance between the two corresponding points on the Argand plane, a specific fact used constantly in locus problems. A genuinely classic JEE application uses the distance interpretation directly for locus problems. The equation mod of z minus z naught equals a constant Besnelli every point at a fixed distance r from the fixed point z naught, which is precisely the equation of a circle center with radius r. Similarly, the equation mod of z minus z1 equals mod of z minus z2 describes every point genuinely equidistant from two fixed points z1 and z2, which is precisely the perpendicular of the line segment of the line segment joining those two points. A frequently tested trap involves genuinely remembering that the argument of a complex number is only defined up to adding multiples or 2 pi. A genuinely classic JEE application uses the distance interpretation directly for locus problems. The equation mod of z minus z naught equals a constant Besnelli every point at a fixed distance r from the fixed point z naught, which is precisely the equation of a circle centered at z naught with radius r. Similarly, the equation mod of z minus z1 equals mod of z minus z2 describes every point genuinely equidistant from two fixed points z1 and z2, which is precisely the perpendicular bisector of the line segment joining those two points. A frequently tested trap involves genuinely remembering that the PK argument P mosh postamenant might Philadnes more continued complex number is only defined up to adding multiples or 2 pi, so the principal argument is specifically restricted to the range -/pi, and you must genuinely determine the correct quadrant from the actual signs of x and y before simply computing the arctan of y over x, since arctan alone cannot genuinely distinguish between the first and third quadrants, or between the second and fourth. Let's recap. Every complex number z equals x plus ii's point on the Argand plane, with modulus r as its distance from the origin, and argument theta as its angle. Addition behaves like vector addition. Multiplication multiplies moduli and adds arguments, and the distance formula, mod of z1 minus z2, is exactly the straight line distance between two points. Powering locus equations like circles and perpendicular bisectors. Getting the correct quadrant for the argument rather than blindly trusting arctan is the most common source of errors. That's the geometric interpretation of complex numbers. Keep the circle and perpendicular bisector locus equations, and the correct quadrant argument check sharp. They unlock nearly every geometry question in this chapter. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE content just like this. See you in the next one.